simplify the expression, right? So first method was to use a Boolean loss, right, in order to simplify the expression. Next method was to use a K-maps, that is a Karnaugh maps, in order to simplify the expression. So the next concept or the next technique that what we will be using in order to simplify the expression is a QM method, which is also called as a Quinn-McCluskey. Okay, QM method is also called is nothing but a Quinn-McCluskey method. So why we have to go for this particular method is whenever our variables are exceeding more than 4. Okay, so the K-map will be very easy for us to simplify the expression if the variables are 2, 3 and 4. If the variables are exceeding the 4, for example, if your expression is having 5 variables like A, B, C, D, E bar, so if the expression is having the 5 variables, then it would be very difficult if you are using the Quinn-McCluskey method. It will be very difficult if you are using the K-map method. So therefore, we are switching from the K-map to the Quinn-McCluskey in order to solve the expression which is having more than 4 variables. But right now, I have considered the 4 variables only. And it is not compulsory that the Quinn-McCluskey is used only for 4 plus 5 variables. Okay, we can use for 4 also. See, this expression can be solved by making use of the K-map also. But we will understand the technique that is called as a Quinn-McCluskey by considering the 4 variable expression. Okay, this particular expression can be solved by K-map also. But in the exam, they will be specifying you to reduce the expression to the simplified form by making use of a K-maps. Then you have to use a K-maps only. Okay, if they are asking you to reduce the expression and get the simplified form by using the Quinn-McCluskey method, then you have to use this method itself. Okay, this is a bit lengthier process. Okay, it will be very interesting. Okay, it will be very interesting. First, copy down the question. Step by step we will go. Do not mess up anywhere else. Okay, what is the question here? F of ABCD is equals to the min terms of 0, 1, 2, 3, 6, 7, 8, 9, 14 and 15. So first take down the question properly. So after taking the question, so this is the first table. So there will be many tables. Okay, there will be many tables in order to get the final expression. So this is one such first table. So in the first table, you have to write the min terms towards the left side and binary representation towards the right side. Okay, this is how you have to write the table number 1. So this is a table number 1. So what are the min terms they have given in the question? Please take down the same thing. So 0, 1, 2, 3, 6, 7, 8, 9, 14 and 15. So these are the min terms which are given in the question. So we shall write down the binary representation for the same min terms. So that is 0, 0, 0, 0, next 0, 0, 0, 1, next 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. Next is 14, right? 14 means 1, 1, 1, 0. Is it correct? 8 plus 4, 12, 13, 14. Correct. 1, 1, 1, 1. See, it is a very important step. If you are going wrong in writing the representation, then the whole problem will be, you will end up with the wrong answer. Okay? Don't write the wrong binary representation. Check once again after writing this table. Check once again whether the binary representation is correct or not. Okay? So this type of a problem will be asked more than 10 marks or 10 marks. So it may be asked for 10 marks or 12 marks. Keep in mind, it is a very easiest problem. You can score 10 to 12 marks very easily, but you have to patiently take down, write down each and every step. Okay, if you are losing your consciousness in any point, you will be ending with the wrong answer. Okay, so this is the first table. Okay, this is the first table, which is represented as T1. Okay, next I will write the table 2. So how to write the table 2? I'll just write down. You just carefully listen. This is the table 2. So in the table 2 also you are supposed to write min terms. Okay, min terms, then the respective binary representation. So how to write down the binary representation for the same? So how to write this table number 2 is, okay, first you have to write the min terms which is having no zeros. having no zeros, so therefore I will write 0, 0, 0, 0. So this is BM0, right? We have to write the minterms here, that is M0, that is nothing but 0, 0, 0. Okay, which is having only no zeros, no ones at all. Next, so which is having single ones. So this is having a single one. This representation has a single one. Next, this has a single one. Okay, that is M1. Okay, that is M1 and M8. Okay, M1, that is 0, 0, 0, 1, and M8, that is 1, 0, 0, 0. This is the second group. This is first group, which is having only single term, which is having no ones at all. This is the second group, which is having a single one. So I have written 3 terms have written. And again I think I can write M2 also. So I think I can write M2 which is having a single one. So therefore 0, 0, 1, 0. See, if you miss out any one term, then it will be very difficult. Please take down properly. Next group will be having 2 number of ones. Next group will be having 2 number of ones. So that is M3. Okay, M3. Next comes M6. Okay, next comes M6. Next comes M9. Okay, M9. Okay, that's all. Fine. M3 is written as 0, 0, 1, 1. Next 0, 1, 1, 0. Next M9 is written as 1, 0, 0, 1. Next group will be having 3 number of ones, that is M7. Okay, that is M7 and M14. M7 and M14. M7 is represented 0, 1, 1. 14 is written as 1, 1, 0. Next group will be having 4 number of ones, that is only M15. Okay, which is represented as 1, 1, 1. Have you all understood how to write the table number 2? It is very important. Make sure that all the minterms are being covered here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 minterms are covered in the table number 2. So it is finished. So now come to table number 3. So table number 3. So how to write the table number 3 is again write down the minterms, which is very important. Follow properly. Minterms and also the binary representation. So minterms and binary representation. So this is the 0th group. So now what I have to do is, this is 0th group, this is first group, this is second group, and this is third group, and this is fourth group. Okay. So now what I will do, I will compare each and every minterms with the next groups. So what I am doing, I am comparing the 0th group and also the minterms in first group. So 0, 0, 0, 0 is compared with. Okay, I'll just compare M0 and M1. So whenever I am comparing M0 and M1, how many number of bits are getting changed? Only single bit is getting changed. Okay, so therefore I can consider M0, M1, or it will be very easy if I am writing only 0, 1. So how to write this now? 0, 1. So 0, 0, 0 is like double to 0, 0 is like double to 0, and 0 is getting changed to 1. So therefore I have to write it as 0, 0, 0 dash. Since this bit position is getting changed to 1, I have to represent it as dash. Okay. Now I will compare 0 with 8. I will compare 0 with 8. So how many number of bits are getting changed? Only single bit is getting changed. So therefore I can include in table 3. Okay, if 2 bits are getting changed, it means I cannot include. So 0 and 8 I can include it, and I can write it as. So since these are getting mapped, you have to put a tick mark. Very, very important. You have to put a tick mark since these are getting mapped. Next, 0 is getting changed to 1, 0 same, 0 same, 0 same. So therefore 0, 8. So this is also getting. This is also is able to group it. That is nothing but dash 0, 0, 0. Okay. Now I will compare 0 with 2. Okay, 0 with 2. So even this is also possible. So I will put a tick mark here, 0, 2, and I will write it as 0, 0, dash 0. Why dash? Why dash? How you will be getting to know where you have to write the dash? Wherever the bit positions are getting changed from 0 to 1, at that place you are supposed to write it as 0. Okay. So the grouping with 0 and 1 is done. So therefore you can put a line here. Okay, you can put a line. Next. So how you have got this particular group? By comparing the 0th group and the first group. Now you are supposed to compare the first group and second group. Okay, that is M1 and M3. M1 and M3 is impossible. 0 is same 0, 0 same 0. 0 is getting changed to 1 and 1 is same as 1. So therefore I can write it as 1, 3 also. 1, 3. So therefore I can put a tick mark here and 0, 0, dash 1. Next I will compare 1 with 6. I will compare 1 with 6. Is it possible? No. See, 0 is changing, 0 is remaining 0, 0 is getting changed to 1 and 0 is getting changed to 1. So since 2 bit positions are getting changed to 1, I cannot put a 2 dash. I cannot put 2 dash in the table 3 itself. So therefore this M1 is not getting mapped with, or you cannot compare with 6. Next M1 with M9, is it possible? Yes, it is possible. So I can put a tick mark here, 1, 9. 1, 9, how I have to write it? Dash 0, 0, 1. Okay, dash 0, 0, 1. Next M8 I have to compare with M3. So first what I have did, I have compared M1 with M3, M1 with M6 and M1 with M9. So in that this 3 and 9 was being paired and this 6 was not able to pair it. Anyway, I should not write all these things here. Okay, it should be very clean. So in order to make you to understand, I have written it. Okay. Now I have to compare 8 with 3 now, 8 with 6 and 8 with 9. So 8 with 3, is it possible? No. See, 0 is getting changed to 1, 0 is getting 2 bits are getting changed. So therefore 8 is not possible with 3. 8 is possible with 6. No, it is not possible. 8 is possible with 9. Yes, it is possible. So therefore I can write it as 8, 9 is equals to 1, 0, 0 dash. See here, the 0 is getting changed to 1. So therefore I can write it as 8 is mapped with 9. Now I will compare 2 with 3, 2 with 6, 2 with 9. 2 with 3 is possible? Yes. 2 with 3 is possible. So therefore I will write it as 0, 0, 1 dash. Next 2 is with 6 is possible? Yes, it is possible. So 2, 6 is equals to 0 dash 1, 0. Next 2 with this 9 is possible? Is it possible? No, it is not possible. Since many number of bits are getting changed, it is not possible. 2 with 6 is possible, so put a tick mark there. Putting a tick mark is very important. Next. So grouping, comparing with first group and second group is also done. So therefore again put a line here. Next, I will group 2 with 3. I will group 2 with 3, 3 with 7, 3 with 14. Is it possible? Yes, it is possible. So 3, let me use a different chalk. So 3 with 7. So 3 with 7 is possible. So 0 dash 1, 1. Right? And 3 with 14 is possible? No, it is not possible because the 2 bit positions are getting changed. It is not possible. Next, compare 6 with 7, 6 with 14. 6 is it possible? No. Yes, 6 is possible. So 6 with 7 is possible. 6 with 7 is possible. So 0, 1, 1 dash. See here, 6 with 7, 0, 1, 1. 0 is getting changed to 1. So therefore you have to put it as dash. Next, 6 with 14 is possible? Yes, it is possible because only 1 bit positions are getting changed. So therefore 6, 14. 6, 14, that is dash 1, 1, 0. Okay, so therefore I have to put a tick mark here. Okay, so 6 with 14 is also possible. 9 with 7 is possible. 9 with 7, it is not possible. 9 with 14 is possible. No, it is 7 and 15 is impossible. So just put a line over here. Okay, just put a line here. So now I am comparing the third group and fourth group elements. So 7 and 15 is possible. So put a tick mark here. 7 and 15 is possible. So that is written as a dash 1 1 1. And 14 and 15 is possible. Yes, obviously it is possible. So 14 comma 15 is equals to what I have tried? 1 1 1 dash. Okay. So this comes the table number 3. Table number 3. I repeat once again. So the table number 1, how we have done? Just copy down the same portion towards the left side and write down the binary representation. And the second table is just rearranging. How we are rearranging? So the first group should contain no ones, and this group should contain single one, and this group should contain 2 ones, this group should contain 3 ones, and this group should contain 4 ones. And how to write table number 3? Compare the terms with 0 and 1. Okay. If there is a single bit variation, then write down as dash. Next, compare 1 with 2. Okay. Next, compare 2 with 3. Next, compare 3 with 4. So you will be getting the table number 3. Okay. Next, we shall go for table number 4. Just analyze once. And write down all these things very neatly. Now we shall go for, now let me name this as 0th group, this as first group, and this as second group, and this as third group. Okay. Putting the tick mark is very, very important. So now table number 4. Table number 4. I am writing as T4. Table number 4. So here comes the main terms and respective binary representation. So now you start comparing the first term, the terms in 0 and 1. Okay. So 0, 1 and 1, 3 is impossible. 0, 1 and 1, 3, can I compare it? See, 0 is same as 0, 0 is same as 0, 0 is not same, it is, you cannot map with dash. So therefore it is not possible. So how you have to do is, 0 0 0 dash iddre. For example, ಇಲ್ಲಿ ಏನಾದರೂ 0 1 0 dash iddre, then you can group it. There is a change in a single bit position. So at that time you can do it. Okay. You cannot group if there is a change in 2 bit positions. See here, 0 is same as 0, 0 is same as 0, but 0 is not same as here 0. It is not. We cannot map 0 with a dash. Is not same, so therefore 0 1 1 3 is not possible. Next, 0 1 and 1 9 is impossible. It is not possible. Okay. 0 with the dash is not possible. Okay. Next, 0 1 with 8 9 is possible. Yes, it is possible. So how you will get to know is, see here 0 1 11. So I will have a dash. I can put a dash. 0 is remained as 0. 0 is remained as 0 and dash is remained as dash. So all the 3 positions are same, only the single bit is getting changed. So therefore I can consider 0 1 with 8 9. Okay, 0 1 with 8 9 I can write. So therefore write it as 0 1 with 8 and 9. So at that time what you will get, 0 is getting changed to 1. So therefore I put a dash here and double 0 dash. Okay, have you all understood? So always keep in mind, whenever you are comparing the 2 terms, only a single bit position should get changed. If it is changing more than 1 bit position, then you cannot consider that particular group or min term. Next, I will compare 0 1 with the 2 3. Is it possible? 0 1 with 2 3, as it is possible. See here. Okay. 0 1 2 3. See here, 0 0 0 dash dash. So 0 0 dash dash. Fine. Next, 0 1 with the 2 6 is possible? No, it is not possible. 0 is same as 0, and in the place of 0 there is a dash. I cannot match that. So therefore I cannot match 0, 1 with 2, 6. Next, now first term has been compared with all the terms in the group number 1. Now the next term is 0, 8. I have to compare with each and everything. 0, 8. So one easiest method I will teach you. So wherever there is a first E combination, the dash is there. First combination is a dash, right? The first bit is dash. So you check for the first bit only. So where the first bit is dash is. So can I compare this and this? Yes. So 0, 8, 1, 9 is possible. Have you understood the technique? The technique is very simple. So E combination the dash and the dash is in the first bit position itself. So therefore the first bit position where the first bit position, this is the first bit position, right? So therefore I can compare this and this. So 0, 8 and 1, 9. So 0, 8, 0, 8 and 1, 9. 0, 8 and 1, 9. So what you will get? 0, 8 and 1, 9. What you will get? Dash, double 0, dash. Dash, double 0, dash. See now, very important thing. See, this 0, 8, 1, 9 is same as 0, 1, 8, 9. In bracket the numbers here, in bracket the numbers here. Right? What is the representation for this and this? It is same. Dash, double 0, dash, dash, double 0, dash. So therefore there is no need to write 2 times. Okay? I can just erase it. If it is there also, no problem. If you erase it also, not an issue. Okay? So now 0, 8 with 1, 9 is done. 0, 8 with 8, 9, is it possible? No, it is not possible. 0, 8 with 2, 3 is possible? No. 0, 8 with 2, 6 is possible? No. Next, 0, 2 with 1, 3, is it possible? Yes. So how it is possible? See, the third position is dash, and here also the third position is dash. So therefore you can check it for that. 0, okay, 0, 2 with 1, 3. 0, 2 with 1, 3. 0, 2 with 1, 3. It is again will be getting it as 0, 0, dash, dash. So now this in the bracket 0, 2, 1, 3 same as 0, 1, 2, 3, and the binary representation is also same. So again I shouldn't write. So therefore I erase this as well. Okay, I erase even this as well. So 0, 2 with 1, 0, 2 with 1, 3 is mapping. 0, 2 with 1, 9 is it's not possible. 0, 2 with 8, 9 it's not possible. 0, 2 with 2, 3 is not possible, and again with 2, 6 also not possible. Okay. Now come to the second group. Okay, come to the second group. So now I compare 1, 3 with 3, 7. Is it possible? No. See here the third bit position is dash, here the second bit position is dash, so it is not possible. 1, 3, 3, 7 not possible. 1, 3, 6, 7. No. 1, 3, 6, 14. 1, 3, 6, 14. Is it possible? 1, 3, 6, 14. Not possible. Okay. So 1, 9 with 3, 7. It is not possible. 1, 9 with 6, 7. It's not possible. 1, 9 with 6, 14. It's possible, I guess. No. No. See here, very important thing. See 1, 9 with 6, 14. Even though the dash is having the same position, 0 is getting changed to 1 and 0 is getting changed to 1. So therefore I cannot put it, or if there is a 2 change in bit position, I cannot consider this 1, 9 and 6, 14. Okay, fine. Next, 8, 9 with 3, 7, is it possible? No. 8, 9 with 6, 7, yes, no. See here 2 bits are getting changed, so therefore I cannot go for it. Next, 8, 9 with 6, 14, no. Next, 2, 3 with 3, 7. No. 2, 3 with 6, 7. Yes. 2, 3 with 6, 7 is possible. 2, 3 with 6, 7. 2, 3 with 6, 7 is possible. On what basis? So 0 dash 1 dash. 0 dash 1 dash. That is 2, 3 with 6, 7 is possible. Next, 2, 3 with 6, 14 is possible. No. Next, 2, 6. 2, 6 I have to compare with all these things. 2, 6 possible, but I shouldn't write why, because the same numbers are present here. So therefore I shouldn't write it. Please take down.